Hello, my name is Tanya, and my team members are Viet and Rebecca. And for our final project, we've created a AI story generator. So for our overall structure, we have the MVC structure, we have the model, the view, and the controller. So I will be going over the controller first. Um, for the controller, we have our main controller, which is basically bringing the whole program together. It sits between the swing views and our service models, so every user action kind of funnels through there. When the application starts, the controller receives callbacks from each setup panel. So that includes like genre selection, character details, world elements, and style preferences. So it stores these preferences in the story model, and then it wires up the right strategy, which will be discussed in the model. And it builds the prompt. So when the user decides to hit like start story, the controller resets the model, triggers any async requests for the first chapter, and it swaps the UI into the story view. And each chapter then requests runs inside a swing worker to keep the UI responsive. And in the background, we build the prompt, call OpenAI, and return a scene model, which is all filtered in through all the service components that we have, which include OpenAI service, prompt builder, story save system, character factory, world factory, all of those. And then for choice handling, when the user picks A, B, or C, the controller logs the decision, advances the chapter counter, and launches the next scene request. So it also forwards any save and load requests, since we also included that feature in our program. And it turns the current model into a saved story model and writes it to the disk. Finally, the controller is also responsible for friendly error handling. So if there's any rate limits or exceptions from OpenAI, it's displayed in the done block in this controller. And then moving on.
Okay, so moving on to the view, pretty much very quickly, it takes care of the user experience. So things like rendering all the UI elements, collecting input, and providing user feedback. We'll just start by going through the input panels when you first open the program. So you have things like genre, character, world, and then also controls panel. The primary function here is just gathering data and handing off to the controller. So like with the genre panel, you can click anything such as like fantasy and emphasis on like it does no processing, it simply collects the input and just passes it back to the controller. And things with like character and world panel, they use like a grid back layout just so you can keep the structure clean and do basic validation. So for instance, if you need a location, it checks for that before calling. And for the controls panels, that take care of things like such as complexity for when you do child friendly or adult. And moving on to the core story experience, when we first click begin, it actually has a loading indicator. So while we're just waiting for the network, it just ensures that the UI never freezes. And moving on to the story panel and the choice panel, this is where Rebecca had improved upon the initial design and made it cleaner here. It's all this stylized in a way that's easy to read. It makes it easier for the user to just choose in between these options, like highlighting over a specific button. It will change to a light gray uh, color. And for the error handling, if you're handling some unstable AI APIs, it'll be able to tell the user that what's going on. So instead of crashing, and then it'll also give a little instruction what to do as well in our error dialog Java class. So if we can move on to the model now.
Okay, so the model layer represents the entire story and acts as the single source of truth. At the top is story model, the aggregate root. It owns the character model, the world model, the story model, or the story state model, and the list of scene model chapters. All story operations flow through story model, keeping the system synchronized and consistent. Character model stores the player's identity, name, traits, and backstory, um, and is structurally immutable, ensuring stable references throughout the story. World model defines the setting, rules, and lore. It is read-only after creation, so narration constraints remain consistent across all chapters. Each chapter is represented by a scene model, which contains the generated text, choices, and metadata. Scenes are append only, making progression deterministic and save load reliable. Story state model tracks progression and enforces business rules such as chapter limits and completion. This prevents invalid transitions at the model level. The model uses composition, not inheritance. These objects only exist within story model. All models are created through factories, guaranteeing valid initialization and eliminating null states. Overall, the model actively enforces rules, owns all state, and guarantees that the story always remains valid.
Okay, so now we're going to be demoing our actual project and how it works. So first we have our menu where you can choose a genre. We have fantasy, sci-fi, mystery, romance, and horror. So we can go ahead and select one. So we're going to do sci-fi and give it a name. And then we can select a character trait. So we can go with brave, I guess. And you can select multiple if you want to. And then you can spell out a backstory.
Oops. Go back to it real fast.
And then some more information about the story and what you want it to look like include like location. So we can say like the mall and then history, just to give it more context of what to make the story about. We can say like
What's that? 1980.
cool. And then we can also select different attributes like the length of the story, the complexity of it. You can have it adult or child friendly, or the style. It can be descriptive, neutral, or terse. And then you can generate a story by clicking begin story, and it will generate the first chapter with, it shows a cool, nice loading bar. And then it gives you your first chapter and 3 choices that you can proceed with. And then it goes up to 5 chapters, and it kind of, in the last chapter, creates an ending to the story so that it's like full circle. And just clicking through that. So this would be generating the last chapter. And that's the end. And so you can also save your story. So in the library, you can see your saved stories and you can load them up. Like so. This one has 1 chapter and so on. We have other few. And then you can also load them up in
We have to like, okay, hold on.
in your
It works best when it's not at the end of the chapter. That's when it works. So it loads up. And so we have it all loaded now.
So right here, we're going to demonstrate some error handling. We have removed the API key, and now we're going to run the program again. And you can see that AI features are disabled because there is no API key to request to OpenAI. So this makes our program more versatile. Yeah.
It also has like default information. It doesn't work. It tells you it doesn't work, but yeah, also another one, a second one, just to tell you, yeah, it doesn't work. And then it tells you here, it needs the API key to work. So it's like a fallback, that kind of stuff. And that's it.
All right. Thank you.